Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker. This is chapter 15, part 1, randomized complete block design. In this video, we're going to talk about the relative efficiency of randomized complete block designs versus a completely randomized design. So essentially what we're asking is to find a calculation of the relative number of experimental units, or if we're studying people, the relative number of subjects needed for a completely randomized design to achieve the same precision when determining treatment effects. The higher the relative efficiency, the more efficient the blocking variable is. So essentially, if we're blocking for things that are true confounders, that ends up being a good thing, and the block design ends up being more efficient. And if you were to use a completely randomized design, you'd actually need to have more replications per treatment. Okay, so we're going to do the example that we were working on last time, where we had the layout of a store as the treatment, or excuse me, the layout of the produce as the treatment. The actual store is the blocking factor. And then we're looking at the sales of that particular store. Remember, we had 5 stores. We had 3 different layouts. The mean square for the blocks was 839, and the mean squared error was 186. Okay, if we'd like to calculate the relative efficiency, the way that we do this is b minus 1, right? That's the degrees of freedom due to the blocks. So that should be 4 times the mean square of the blocks, 839, plus b times t minus 1, which is 2 times your mean squared error, 186, divided by bt minus 1, right? So that's 5 times 3 minus 1, or 14, times our mean squared error, which is 186. Okay, at the end of the day, all of this is equal to approximately 2. So what we have is that we would need twice as many replications per treatment, so per layout, for the completely randomized design to have the same precision in the treatment effect estimates as the randomized complete block design. So overall, we would conclude that the blocking by store was effective because we didn't have to have as large of a sample size as the completely randomized design.